Hello, today I'm just going to be walking you through how to use the unit testing system for your own endeavours. Ideally, I would be doing this in the project and showing you how to use it in the project being P-Engine. However, since the person who uses CMake couldn't get it in last week, the week before the holidays, because they were gone on Thursday, I decided to just make this basic project and show you how to use it in that. So, without further ado, don't know why these are open. Without further ado, I'm going to show you how to use it. The first thing you want to do is you want to include the library. Now, this will probably be different for CMake, but for non-CMake, if you're using the MSCV compiler system, it's basically you want to go to include with quotes, and then you want to type in RTUTS? Nope, not that. RTU. This, and then you want to click one-time unit testing system. Now we have the access to the library, because it is a library, and then after that, to do something with it, we want to create something like a I forgot the namespace. UTS. And we want to create something like a tree constructor. You can create a list constructor, or a binded list constructor would probably be better. But for this example, we're going to use a tree constructor. List constructors, though, and binded list constructors are very easy to understand how they work. They're much simpler than tree constructors. So if you can understand how a tree constructor works, you can understand how they work. So we're starting with a tree constructor. I'm going to call this main tree. You can call it whatever you want though. And then we're going to also construct it. Where is it? Now that we have our tree constructor, what we can do is we can use the RTS UTS namespace, or RTUTS namespace should I say, and we can go to con output test results. You don't generally want to use this or this, just use this. If you want to print out the test results to the console, use this. And this, well, do the shocking thing of outputting the test results to the console. To get that to work though, you want to put main tree, then you want to use get container. This basically returns a data structure called data container that can store data and represent data in multiple ways. It can be represented as a tree, as a list, or array, or what have you. It's a really useful thing. It allows for multiple constructor formats. And this is basically what the constructor constructs, the container. Shocking. Anyways, then we move on to our settings. And then we're going to construct this. Anyways, for our settings, we're going to have output when notices to on, and that we don't really want to mess with. This is not a setting you really want to mess with. It's basically, if you have a binded list, which is basically a list in like a sort of folder, and that folder's hidden, this shows you the hidden folder. Shocking. But you don't really need to mess with it, and yeah, you just don't need to mess with it. I'm gonna also turn this on. And now, if we run this as it is right now, we're just gonna get that. We're gonna get our tree, it's gonna have nothing in it, and it's not gonna print anything else. It's not very fantastic. So let's add stuff to our tree. The first thing we're gonna add is we're gonna add a domain. And we're gonna do this by using push domain. We're going to type in the type of the domain we're pushing, so namespace. And then we're going to also give it an identifier. The identifier is basically the name of the namespace. So in this example, we're going to use PENGINE. I probably spelled that wrong, but it doesn't really matter. And we're going to call it AI. So we know it's in here. If we really wanted to, we could push 2 namespaces, but it's not worth it. And we're going to also pop the namespace, and we're going to do this by using pop domain. It is very important that for everything we push, there is a pop. If we push something and it does not get popped, you will make the thing go unstable. That is bad. We don't want that. I mean, you won't really make it go unstable, you just start confusing the layout system as it tries to put everything together. It will find a way to put everything together, but it's not going to be good. But if you pop the domain too many times, that will make things go unstable. That'll make us go into the negatives. We don't want that. The system was not built for negatives. So make sure that for every push there's a pop, and for every pop there is a push. Anyways, then we're going to go to do this again. Push another domain. I'm going to call it a class. I'm going to call it manage MEB agent. And this is just for an example. Now, we could, if you wanted to see what that looks like, we could do this, and we'll get this. MEB agent doesn't have anything under it. Things that don't have children don't get brackets. It's an easy, efficient way of collapsing folders and stuff. Also means we don't have to put in much work in discerning between tests and domains, because they are very much alike. And that is very more apparent when we get into actually making the test work. But yeah. Anyways, after this, we're not going to push another domain, we're going to push pop and notice. Now, because it's push and pop, you don't need to pop anything here. It will add it and remove it. Well, it doesn't actually remove it, it just removes access to it. When you push something, you add something. When you pop it, you're just removing access. It's still there. So we can't access this and add anything to it, but we can add it. That's effectively what this means. I'm going to say running agent test. That doesn't need to be a capital. And now if we run this, Oh yeah, something that's very important here. Whenever this gets run, I forgot how you do this with like nothing inside of it. Hold on. Actually, okay, I'm back and I'm forward winding this. I did a earlier example of this and just basically we going over that. I forgot you have to put a null pointer there. But you can use run test, that's how you run the test, and whenever that gets executed, that's when it will run the test. It does not automatically run them on startup. And I mean, that's very much apparent given that you have to pass into this constructor object, and that does not exist in startup. It's not a pre-compiled program or anything like that. You have to do it in runtime. That's why it's called the runtime unit testing system. So that means you have to call this at some point in order to actually get the test to be executed. But if we do that, we'll now also get this notice. It will say running agent test, and we can also actually see where the notice is in the structure as well, which is nice. So then, for the moment you've all been waiting for, test. Let's add a test to this. I'm gonna call it example. And now it's requiring a unit test object. But what is a unit test object? Glad you asked. A unit test object is a function that returns ts. It returns, I can't remember exactly, but I know it's somewhere here. It returns that. It also takes in type void pointer. So we can call this example test. And just like that. That is what test is, and then we can put that in there just by copying the name and putting it here. If you want to know how to do that, is just copy this part, the yellow part, put it there. I'm telling you that just because void pointers and function pointers, not void pointers, but function pointers, maybe void pointers as well, are a bit new to some people. So this is a function pointer. That's what this is. That the unit test, that is a function pointer, and it basically means you can slap a function name in it without it being in quotation marks or anything like that, and then it'd be like, oh yeah, I gotta execute this whenever we want it to execute, which is when we run tests. So now, oh yeah, this must return some results. So I'm gonna put in some. Also gotta set the what was the result. You can do that by doing this. we could set that to fail. And now, run that, it'll get a bunch of red things. The red things are bad because it means something failed. That's a key takeaway from here. If it's not green, it's not good. But yeah, we can do that, and we can copy this and make more tests of different types. We can also just reuse the same test multiple times. It won't check, but you shouldn't need to do that. But you can. I could make this simple test B. And what we can do is we can do that. Now, something you probably notice is this green things, these were originally green and now they're red. How so? What happens here is the things that aren't really tests, like these, they inherit the worstest value from the tests below. So all these are inheriting this one's value because it's a worse value than everything worked out well, which is what green is. Green is everything worked out well, it's all fine. But it inherits red because red's bad, and then this inherits red, then this, and so on and so forth. It's an effective way of being able to see if something's gone wrong immediately, because you just have to look at the top and you'll be like, ah, red, that's not good. Compare that to, say, a list extractor, which basically just spits out the list of test results and you have to scroll through them to find out if something's gone wrong. If you want to know if something's gone wrong immediately with list constructor, it just doesn't work. This does allow you to know that. And that's the difference between a list constructor and a tree constructor. Trees are better at allowing you to know something went wrong quicker. And also where. Because we've done this in like a namespace in a class. We know where that class is. We don't have to distinguish that information in the actual test name itself. We could just be like, ah, it's this class. Super effective. And we can also add another domain here. And you can see that it inherits the worst thing in action if we do that. Well, no, I wanted to pop domain there. And if you're wondering where's the tree aspect coming into this, the domains are basically the child-bearing nodes of the tree. The tests are the leaf nodes. In case you haven't put that together yet. Well, now you know. I'm going to call this bad. You don't have to give domains a type if you don't want to. Shocking, I know. I'm going to call this good. And if we do that, as you can see, bad has inherited this, and then this is inherited from bad, and this is inherited from MEB agent, and so on and so forth. But good is inherited from, well, one of these. It's probably going to be the first one. So, yeah, that's really much how it works. You'll still get this printed into the console when it runs the tests. Now let's do something a little crazy. Let's get it to print, not print, let's get it to send its results to an external program. This can be beneficial for a lot of reasons. You may have noticed that the test results have a lot more to them than just the severity code. They have all this. What does all that do? Well, what all that does is RT yes. And then what we can do here is we can use this test results. Then we can set a file location for something. So an object location is basically the class of what is currently being tested. The test result location is basically the test result location. Shocking, I know. We also got a description buffer that we can put in descriptions to. So let's add a simple description. Testing 1, 2, 3. And then also, because it failed, we can just also add in come on. There we go. We can add in the file path for our object. Well, there isn't really an object. For test results then. Yeah. So this will be, I think it will be, I might be completely wrong on this. You also have to add 4 slashes because it serializes this to JSON. Well, JSON doesn't allow 1 slash between things. It's very annoying. So you have to add 4. If you screw this up, it will not work. So make sure you don't. And then we're going to call this test.cpp. And I think that'll do it. Let's see if the description prints. It does. This is where the descriptions get printed in arrow brackets. Now let's print it off to an external program. Send it off. Keep getting that confused. To do this, we use RTS UTS ext output test results main tree.get container, and we want the output settings. So let's delete all this real quick. No, that's not right. So project is in line. This is something you might have to keep an eye on. What this means is are you looking for tests relative to the executable location or relative to the project location? If it's true, I believe it'll be relative to the executable location. I believe. I can't remember. Oh wait, no, that's the other way around. Never mind, forget what I just said. If it's true, it will be exported to the parent folder. Yeah, that basically means the project folder. Forget what I just said. If it's true, it will be exported to the project folder, and I believe that will be true by default. We also got this. We can wait, which basically forces us to wait for the last set of data outputted to be collected by the external program. We're going to set that to false because I can't be asked to wait. And then the first thing you don't really need to mess with again. So now it will output our results to an external program. But what external program? How to read it? All that. To read it, what you want to do is you want to find this. This will contain the external program. However, it will be in the zip folder called binary. It's in here because of how annoying GitHub is. What you want to do is you just want to drag this out of here, then you want to open it up. and you want to make sure you select the project folder. I think I have the project folder, and hit presto. Now look at that, it's in our external program. You can even click that button to see the notices. And hopefully, if I'd done this right, I don't think I've done it right. Well, if I click it again, maybe it's just trying to get me to go to the welcome page really much. No, I did not do this right. I screwed it up. Ah, that's unfortunate. Is it not testing? Hold on. Stop it. Here's test. Test.cpp. Maybe I'm adding an invisible character somewhere. I know it does work. I've tested this multiple times. It's probably just an invisible character somewhere. Anyways, in here you can see the test results. It will also merge the results automatically. So if we do multiple tests, it will just merge them together if it can. Which does explain why we have only one example B. All that's been merged down into one. But this is convenient so that you can have multiple things all under TreeRoot, which is nice. It means you're not having multiple routes to go through every time you update the test result and stuff, which is very nice. But yeah, you got that. All that. I should mention though, it's not like magic. If you get better results in the next execution, it won't show you them because the merger will just show you the most severe things. So you'll need to click here results for that, which is why it exists. You can also disable scanning if you wish to do so, which is convenient because, well, if you change the things, like new information pops up here, or I should change what show notices is set to, it'll expand everything out again. So it's just convenient for that. And yeah, this is the unit test results in an external program. That's pretty much it. I mean, I'm sure there are other things you can learn about if you really wanted to. If you read into it, everything does have a very comprehensive description to it. So you could figure out what other things here do, like what does replant do? Does something for Dwart. Yeah, anyways, goodbye.